Hello everyone. In this video, I want to provide an introduction to machine learning. You've probably heard about machine learning in the news, or perhaps you know some people who have worked with it, or perhaps you've read about it or seen it in action. So machine learning is really popular in the last couple of decades because of its ability to generalize important notions or concepts from data that can be used for new data. So at a high level, machine learning is building and using models that are learned from data. Now, depending on who you ask, everybody has a different definition for the relationship between machine learning and artificial intelligence and data mining. But here's kind of my take on how machine learning fits into AI and data mining. So I think about AI as kind of this superset, and inside of AI is ML, which is a subset. But ML is growing rapidly, and so I'm going to kind of draw a circle around ML to say that there's a lot that goes on in the advancements of ML application and research that probably isn't quite classifiable as AI. So when I say AI, what do I mean? Typically, in like one short sentence, I would say AI is implementing human cognition on a machine. Now, machine learning, as we know, has the word learning in it, and learning is part of human cognition. So that's why machine learning is often classified as a subset of AI, because it's implementing one part of human cognition, which is learning, on a machine, hence the name machine learning. So the kind of short description I would put down here for machine learning is learning from and making predictions on data. We're going to see a few examples of this in the video today. Now, also talked about with AI and machine learning is data mining. I'll say DM for data mining. And also, depending on who you ask, a definition for data mining or how it relates to AI and machine learning can vary greatly. So I like to think about data mining kind of outside of artificial intelligence, perhaps over here, but with some ability, of course, to overlap as well. So a short definition for data mining would be discovering and using patterns in data. So what would be an example of data mining? Perhaps you've collected some data about individuals' day-to-day patterns, and you notice that typically on Friday mornings, they do a particular activity like exercise that they don't do other days of the week. So you found a pattern in their behavior. So discovering this pattern would be an example of data mining. Now, you could use this pattern as input to machine learning, where you're saying, okay, I want to model a set of individuals' behavior, and here's an example of how one individual behaves on Friday mornings. And then perhaps for a new individual, you could find similarities to the individuals you've already tracked the patterns of and say, okay, for this new individual, I make a prediction that they may also have, Friday mornings where they do exercise, right? You're learning from past examples to make predictions about new unseen examples. So that's kind of how I see data mining and machine learning fitting together. When you use the discoveries from data mining as inputs to machine learning to help a model learn a phenomenon or a pattern, then you have an intersection between the two. So this is just a rough diagram, high-level 30,000-foot overview of machine learning and how it fits into artificial intelligence and data mining. All right, so let's dive a little bit more into machine learning. So machine learning typically has two main classifications to it. So the first is supervised machine learning, and the second is unsupervised machine learning. So with supervised machine learning, you have what's known as labels, which are assigned from a supervisor. Okay, so the supervisor is considered to be a knowledgeable domain expert or an oracle. someone who's like the teacher, right? They know what the right answer is. So you have some examples of some instances, perhaps going back to people's behavior. Maybe you have behavior data from 100 people, right? And this expert, right, is going to provide a label perhaps for, is each one of these people exercising a lot or not exercising a lot? Are they healthy? Are they not healthy? Are they older? Are they younger? Are they going to live a long time? Or are they going to live a short life? These kinds of things, right? These are labels, right? So some knowledgeable expert provides the labels for each example, each instance of data. That label is what you are interested in predicting for a new example, one that perhaps the teacher or the expert hasn't seen before. And then with unsupervised machine learning, you don't have any labels. There isn't a particular attribute that you are interested in predicting for an unseen example. So with unsupervised machine learning, we really rely a lot on data mining to look for patterns or natural clusters or natural groupings. So we're going to start with supervised machine learning, and then we'll see an example of unsupervised machine learning. So supervised machine learning typically follows this data flow or this workflow. So I put the citation here for where I got this from. It's on Wikipedia, where you can see that we have labeled observations, okay? These are examples, and they might come from different individuals, right? Users of a website, participants in a survey, for example. And some domain expert, knowledge expert, teacher, Oracle provides labels for each one of these. Maybe they say these ones are stars and these ones are tildes, right? They provide some sort of label, okay? Then this data set gets split into two, okay? So it gets split into a training set, which is used to teach or train the machine learning model how to differentiate between the labels, like differentiate between stars and tildes, and a test set, which is used to evaluate how well did the model learn, okay? So you have output from this system, which is a prediction model that can be used on unseen instances. So if we have another person over here with no label on it, we can provide it to our prediction model and find out, is this a star or a tilde, right? What label would this machine learner predict for this unseen example here? An analogy that really helps with learning machine learning is to think about a student and a teacher, right? So your teacher is like your Oracle, your expert, and they're going to teach a new concept to a student. The student is like your machine learning model, your machine learning algorithm, okay? So the teacher has to come up with examples for what they want to show to the student and say, this is what describes this label. This is what describes this other label. And then the teacher, right, summarizes the important points and the student takes it all in. It's like, okay, I think I understand what the differences are between this label and this label. Test me on it, right? So then we have a test set where the teacher gives essentially an exam to the student and says, here are some examples where I haven't given you the label. Give your best guess at what label should go on each of these examples. And then, of course, the teacher is going to grade that exam and provide some sort of summary statistic about how well the student did, right? If there were 10 examples and let's say the student got 9 out of 10 labels right for these 10 examples, then we might say, oh, they have a 90% accuracy, right? And then we might investigate, well, why did the student get this one example wrong? Why did they say this was a star when it was a tilde? And then we could come back to how we taught the student and improve it so that this student or future students learned this phenomenon or learned these differences between stars and tildes, these different labels, better. Okay, so really machine learning is modeling how students learn. The student is the model and the labels come from a teacher. Some important takeaways from this is what the teacher chooses as the labeled observations used for training are really important, right? The higher quality of the training set, the more likely the student or the machine learning model is going to learn the difference between different labels. You also want your test set to be quite representative, right? If you have a really small test set, then you're probably not capturing all the variability in the different labels in different instances. All right. I have an example here that I would like to go through with you. And this is an example of classification. So typically, supervised machine learning is broken down into two different types. So classification is when the labeled attribute is categorical. Okay, like star or tilde, okay, short or tall, old or young, click or no click, right? These are examples of classification because the attribute that is your label is categorical. On the other hand, we have regression. So regression is when your labeled attribute is continuous. So for example, let's say you were trying to predict the age of a user, right? So we're not saying young or old with some sort of category. We're instead wanting to predict a numeric value like 30.5 or 72.9. Okay, so our measurement scale for our attribute that we're trying to predict is continuous. All right, so the example we're going to do here is an example of classification. In particular, this is binary classification because our label has only two categories, cat and dog. So let's say that you have no notion of a cat or a dog, right? No prior information to follow back on. And I am the teacher, and I want to teach you the difference between a cat and a dog. So I'm going to use images in order to teach you. Those are going to be my examples. So I choose these 8 images, and I tell you that the first 4, the ones in this row, these are all cats. And then the next 4, all the ones in this row, these are all dogs, okay? I would probably want to point out some key characteristics that are different between these cats and dogs, right? So for example, I might say that perhaps cats have lighter color fur than dogs, right? Because based on these 8 pictures, 8 examples that I chose, all of the cats have lighter color fur than all of the dogs. So I'm going to keep track of characteristics that differentiate between my labels, cat and dog, in a nice little table. And I'm going to call the characteristic a feature. So a feature is like an attribute in a table. It corresponds to perhaps some column that represents a piece of information about each one of our examples or instances or rows. But when we start working with machine learning, we typically call these attributes features. Okay, so I'm going to have one feature. I'll call it fur color. And then I'm going to provide what value of fur color do cats have and what values of fur color do dogs have. So I'm going to say that cats have a light fur color value while dogs have a dark fur color value. Okay, so I'm helping you, the student, learn what are some key features you can look for in images of animals to determine if this is an image of a cat or a dog. Well, if the fur color is light, it's probably a cat. If it's dark, it's probably a dog. Okay, let's do another one. So something that differentiates the first row from the second row is whether the animal has their tongue out or not, right? So all of these cats, they have a closed mouth, but all of these dogs have an open mouth and their tongue is hanging out. So the cat value for tongue out would be no. The dog value for tongue out would be yes. Let's do one more feature here. Let's do a feature for ears up. Yes or no, true or false. All of the cats have perked up or pointy ears, right? So I'm going to say yes for the cat value. but all of the dogs have down ears or floppy ears, so I'm going to say no. What I've effectively done is provide 3 different features that a student like you could use to differentiate between cats and dogs. Now, what is really important here, and like I said earlier, the examples you use for training are incredibly important, right? We know that some dogs have light fur color, and some dogs have pictures of them with their mouths closed, right? Some cats have pictures with their tongue out, and not all dogs have ears down, for example, right? So the choice of examples used for training is very important. Also, the features used for training and describing your data examples are really important as well, right? You're only going to produce a learner as good as your training set and your features you use to describe that training set. All right, so let me scroll up and kind of remind you where we're at. Okay, so we just went through our training set and looked at some labeled observations, right? We know which ones are cats and which ones are dogs, right? And you just learned the difference between supposedly a cat and a dog. So now we need a test set to see how well you learn the difference between a cat and a dog, right? With this, we can evaluate your performance and see, did you learn cat versus dog very well? So here's our example right here. Here's a new image that you haven't seen before, and using what you learned from the training portion of our session together, is this a cat or a dog? Okay, so let's go back to our table here. All right, I'll kind of keep track of a little score here. Cat versus dog. Okay, so what is the fur color of our new unseen example in our test set? Well, it's light, so that would be a vote for cat. Is the tongue out? Yes or no? Yes, the tongue is out, so that would be a vote for dog. Are the ears up? Yes or no? Well, the ears look pointy, right? They look up just like they do for our cats, so that would be a vote for cat. So now the student, right, you would have to take this information and produce a label, right? Cat or dog. So because you have more indicators that this is a cat, you would probably make the prediction that this is a cat, right? We are knowledge experts, so we know this is actually a picture of a dog. So perhaps our model we built using these 3 features to describe this training set wasn't very good, right? It didn't generalize very well to an unseen instance in our test set. So just to recap, what's important when thinking about supervised machine learning is, what examples are you going to put in your training set? What examples are you going to show your learner, your machine learning model you're trying to train? Okay, what features are you going to use to describe those examples, right? If you have high quality features that are highly generalizable, then you're more likely to capture all the variability in your examples that might be in your test set, right? All right, this is an example of binary classification, right? We had 2 labels, cat or dog, and we had a training set and some features that we used in order to build a model for what is a cat versus what is a dog. We applied it to a test set that had only 1 unseen instance in it, and we made a prediction of cat, which we know now is wrong. All right, this is an example of supervised machine learning. So let's take a look at unsupervised learning. So with unsupervised learning, we do not have any labeled training data. We have data and we're trying to mine patterns from that data. So for example, let's stick with our cat and dog example, okay? Now recall, with unsupervised machine learning, we don't have the notion of a label like cat versus dog. So even though we know we've got 4 cats and 4 dogs here, this is really just 8 images of animals. For an example, I've ordered these images from lighter fur color to darker fur color, where I've got these really light colored cats over here in the corner, and then I've got this black lab over here in the other corner. And just for fun, before I forget, this guy right here is my dog Odin. So kind of an Easter egg that he snuck in there a little bit. All right. So I've ordered these from lighter color to darker color, and perhaps I might be looking for a pattern in the data, or maybe a natural clustering of the data, or maybe some associations of the data. Let's say I'm looking for two clusters, okay, or two groups. If I'm looking down the axis of color, then I might say, okay, well, all of these images seem to have lighter color, and all of these images seem to have darker color. So I've got two natural clusters based on fur color. Now, I just want to emphasize that even though these happen to be cats versus dogs, this is an unsupervised learning example. So I don't have the label of cat versus dog. I just have now blue group and red group. Blue group have light fur color and red group have dark fur color. So now let's say we have a new example. Here's our new example right here. We want to say something along the lines of, this new example belongs to the blue group or to the red group. Well, this new example probably would fall right in here somewhere, right, based on his fur color. So I probably put the new example right here. And so this new example mostly belongs to the red group. So I might say that this new example belongs to the red group, or the red group which has darker fur color. I might further investigate to find out what other characteristics or features differentiate the blue group from the red group. And there I might find out that all of the dogs are in the darker group and all of the cats are in the lighter group. But the key here is I'm not trying to predict cat or dog, right? With this particular example of unsupervised machine learning, I was trying to build two groups and then be able to take a new example and put this new example into one of the two groups. I want to emphasize that there are a lot of different unsupervised machine learning algorithms. So clustering is one of them. So like k-means clustering is common clustering algorithm. There's also hierarchical clustering. Besides clustering, you can do association rule mining. This would be like, for example, at a grocery store, people who manage the grocery store are typically interested in what kinds of products are purchased together, right? Like if a cart has graham crackers, marshmallows, and chocolate in it, and those three items are typically purchased together in lots of carts, then maybe these three items are associated together, right? Because people are building s'mores with them. So they should make a display where they sell these three items together. Or in the store, when they have marshmallows for sale, they should also put graham crackers and chocolate right next to the marshmallows. So that'd be an example of association rule mining. There are a lot of unsupervised machine learning algorithms. This is just an example of one where you're clustering. Also, I'll scroll up here and say there are a lot of examples of different types of machine learning. So we saw a classification example, particularly a binary classification example where our label only had two categories, cat or dog. But you could have classification with 3 different categories or 10 different categories. You could also do regression where you're trying to predict a continuous attribute value for your label. All right, that's it. Thanks for watching.